3:05, let's go. Okay, now it's 3:05 and we'll be starting with our workshop. So good afternoon everyone and welcome to Building Blocks March conference. Today, we'll be talking about data manipulation with NumPy and Pandas, both of which are Python libraries. I'm Shin Sing and I'm from Hua Chong, and a fun fact about me is that I rely on energy drinks a lot.
Hi, I'm 1 year closer to the grave. I'm Shivani.
We'll be starting off with NumPy first. These are the topics that we'll be covering in this workshop, ranging from more beginner-friendly items to more advanced topics. Starting off, we'll have a short introduction about NumPy and why we use it. Then we'll move on to a comparison between list and NumPy arrays to show why NumPy is more preferred. We'll also talk about the accepted data types then in NumPy and also the operations that we can do on NumPy arrays. After most of the theories are covered, we'll also start on some basic NumPy syntax, like initializing your first NumPy array. We'll also go on to teach you some functions like concatenation between two NumPy arrays too. After covering the more basic parts of NumPy, we'll move on to some of the more advanced functions, for example, matrix multiplication, transposition, and broadcasting. And before we conclude the NumPy part of this session, we'll also have a short mini project that will take around 15 to 20 minutes to let you apply what you have learned in this first section of the workshop. But before we start, do ensure that your Google Colab has been set up with the practice file that we have sent in the chat for the Google Meet. We'll give you around 2 minutes to do so if you haven't. We have also just sent a poll into the Google Meet just to check if our audio is all right with y'all. Okay, that's good to hear.
If you are done with setting up the Google Colab, can you please click yes on that as well, on that poll, so that we know that we can move on.
Okay, Kat, we'll be moving on. And with that, let's begin our introduction to NumPy. NumPy is short for numerical Python, and it's a library that allows us to do more with our arrays. For example, we can create multi-dimensional arrays, etc. Unlike arrays, which allows you to add new elements after you create it, NumPy arrays are fixed. And we still use NumPy because it helps us to increase the efficiency of our program. Another benefit of NumPy is that we can use, for example, your plus operator, your minus operator directly between two NumPy arrays. And that's way faster than using a whole for loop just to get the result that we want. As NumPy arrays relies a lot on some of the list concept, we'll have a quick list recap for those who didn't go to the Python workshop this morning or might have forgotten. So what are lists? Lists are containers that's able to store many different data types. For example, it can store your string, which are your text. It can also store Boolean, which are like true, false, 0, 1. It can also store your float or integer values. For list syntax, if you do want to add new elements to, for example, this list, you can use .append behind the list name. In this case, our list name would be L, and we can add the new elements in the brackets over here. If you want to get the length of the list, which would mean like the number of items within this list, you can use len and the list name. And if you do want to access a specific element at X position, for example, I want to access the second item within this string L, we could use the list name and position -1. We use -1 because Python is 0 index, which means we, instead of starting from 1, we start from 0. So as mentioned before, some of the main key differences between this and NumPy would be you can't add elements after you create your NumPy array, but you're able to do so for lists. You can't perform direct arithmetic operations between two lists, which are like using a plus symbol between two different lists, but you can do so for NumPy arrays. And for NumPy arrays, it uses lesser memory because it's like your array is fixed after creation, then you won't be able to keep adding items. So usually we'll have lesser memory for NumPy. These are lists of the NumPy data types, but the highlighted ones are the ones that we'll be using more commonly. Now, we'll be creating our first NumPy array. You can follow along with your Google Colab workbook, and all you have to do is give your NumPy array any name. It doesn't have to be this. It could be like ABC or it could be like anything under the sun, as long as it doesn't have any keywords that are usually used in Python's library. Then you use $sign and you use np.array to create your NumPy array. Similar to list, you can also use the square bracket and position -1 to get the specific item at that position within the NumPy array. We can also initialize data types for NumPy arrays using the comma d type equals to the data type of these values. Or what most people will do usually would just be to add the values directly, as the NumPy array will automatically sense the values inside and adjust its data type accordingly. But some reasons why people might still use this would be to make their code a bit more clear to other people who are collaborating with them. Next, we'll be moving on to NumPy operators. In this section, we'll learn more about how math can be used in NumPy. So starting off with some basic arithmetic operations. We'll first initialize a NumPy array to have the values 1, 2, and 3. You can increment each value in the array just by using the variable storing your NumPy. In this case, we have x, and we can add a plus equals 1 behind. This will allow us to increment each value in the NumPy array by 1. So like 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. And we can do so for subtraction, multiplication, and division. For those who might not know what plus equals mean, it's just a shorter form to say x equals to x plus 1. So as we mentioned before, there are some key differences between list and NumPy array, and one of them is that we can't perform direct arithmetic operators on them. So if we do want to increment each value in the list by 1, we'll have to use a for loop over here. And we will have to look through each item within this list and plus 1 to each of these items. And our final output will be 2, 3, 4. But for NumPy array, we can just use this one statement and we'll be able to get the same results. We can also carry out arithmetic operations between two NumPy arrays. For example, in this case, I've initialized two NumPy arrays to be x and x2, with x having the values 1, 2, and 3, and x2 having the values 4, 5, and 6. By using the plus operators between these two NumPy arrays, I'm able to add up both of these items. This can also be applied to your other arithmetic operators like minus, times, and divide. But do take note that your arrays must have like the same number of items and the same dimension for this to be able to work. So you can't have like, if x had like 4 items and x2 had 3 items, this wouldn't be able to work out. We also have some more basic arithmetic operators. Dot sum will mean you sum up all the items within your NumPy array, which in this case 1 plus 2 plus 3 will give you 6. The dot median will give you the middle value within this NumPy array, which in this case will be 2. If we want to find the smallest value in the array, a faster way to do it would be to use dot min and the NumPy array name. And if we also want to find the location of where this minimum value is, we can use dot argmin, and our output will be 0. Similarly, we can also use it to find our largest value and the location of the largest value within the NumPy array through dot max and dot argmax, which will give us output, which will give us 3 and 2 respectively. I'll stop here for around 1 minute for those who might need to copy the code for their workbook. Okay, then lastly, we'll also have Boolean. And for Boolean, you can use like these arrow symbols to represent greater than, greater, equals, less than, equals. And what it does is that between these two NumPy arrays, it will compare each item at the same position. So for example, at the first position, is 1 greater than 3? The answer is no. Thus, it will output false in the first position. Then it also check, is 2 more than 4? This is also not true. Thus, it will also return false. Lastly, is 5 greater than 3? Because this is true, it will output true, and we'll get this list of all the Boolean values. We'll also have more operators in NumPy, which are like matrix multiplication, percentile, and quantile. But for this workshop, we'll only be going through matrix multiplication in the later sections. And now I'll be passing the time to Shivani to share more about basic NumPy syntax.
Thanks, Shamsin. Data is stored in NumPy like multi-dimensional arrays. So axes are defined for arrays with more than one dimension. So with that, let us now dive into 2D arrays. A two-dimensional array has two corresponding axes. The first running vertically downwards, and the second one running horizontally across the columns. So that will be called axis 0, and the second one running across the columns will be called axis 1. So basically what this means is that the y-axis that you learn in math is axis 0, and the x-axis that you learn in math is going to be axis 1. So while it's supposed to run downwards, right, I've made it like easier to understand by using the axis of a math graph. So for you to visualize and understand. So how would you source the element 6? You see that you can use array 1, 2, but what exactly does this mean? Since NumPy arrays are zero-based indexing, right, it means the row with the first index and that is the second row, and the column with the second index, which is the third column, will source the number 6. Understand? So moving on, even if array has 3 rows or 2 rows, the columns, 3 columns or 4 columns, as long as it is a two-dimensional thing, it is still a matrix. So how about 3D arrays? Can you just enter an extra line and continue? That's not possible. So even if, I'm sure you would have learned that what a list is and what a nested list is. So you would have to create a nested list. As you can see in your notebook or on this slide, you'll be able to create a 3D array by creating a nested list. So a pre-content quiz. What is the shape of this 3D array? Shamsin will be launching a poll in the chat, so you all can make use of it to answer. Is the poll launched?
Okay. If you do have any questions, you feel free to type it in the Discord chat.
Yeah. Regarding the slides, right, if you're worried that you need to refer it, right, before the NumPy project starts, we'll send the slides into the resources forum in the Discord chat so that you all can have a look at it. Okay? What's the poll like? Okay, this is a bit of a mixed answers. I'll give you about 30 seconds more to vote. There's only 27 votes and like about 100 people here, so please vote. You know what? Never mind. So it's actually 2, 3, 4. So the shape will have a syntax of number of planes, rows, and columns. So imagine, right, in math, we want to have an x-axis, y-axis, and z-axis, right? The z is the number of planes, the depth of the thing. So for example, a Rubik's Cube, right? This is the x-axis, this is the y-axis, this is the z-axis. So when you have the z-axis, you're going to have the number of planes, which is like the z-axis of sorts, and then you're going to have the rows, which is this way, which is y of sorts, and then this is the x of sorts. So that's how you kind of visualize things. So please do not confuse this with the zero-based indexing, because in zero-based indexing, because in this case, you're counting the number of planes, or you're counting the number of rows and columns. You're not giving them an index to begin with. Okay? So 2, 3, 4 is the answer. So let's have a look at matrix basics. Kind of need your camera. Okay. So we are moving to a whiteboard, neither whiteboards here. Bring back school memories and power. I know it's the first day of break, so let's go. So, so in a matrix, right? Let's start with the table first. So imagine it's a table, okay? We're going to have one table here, 1, 3, 5, 7. Okay? Go with that. Then you add it to another table, which is 11, 13, 15, 17. What would the result be? This is quite easy because, I mean, the thing is why we're doing this is because we know a lot of kids here are set 1 and set 2 kids. So we want to make things easier. So we add this one to this one over here. And then this one to this one over here. This one to this one over here. This one to this one over here. So what it would result in is 12, 16, 20, and 22. Got it? So this will be represented, since a matrix is not a label, okay, it's indicated by a square bracket. So this is how you will be presenting a matrix. Understand? Okay, so similarly, this goes for minus as well. We're going to minus this, so we 1 minus 11, which will be negative 10. And then 3 minus 13, negative 10 again. 5 minus 10, 5 minus 15, which is negative 10 again. Oh my god, I love negative 10. 7 minus 17, negative 10 again. Okay? There you go.
Shivani.
Matrix for you.
Shivani.
Yes?
Yes, I think people are saying that the ink is very faint. Do you want to try like annotating on a blank slide or something? Because I don't think they can see, like the camera is not working, not being very clear and very helpful.
Okay, so let's just refer back the slides, yeah? The slides are just here. So let's just use this as a template of sorts, okay? You see that 1 plus 3 is going to be 4, 3 plus 8 is going to be 11, 5 plus 9 will be 14, 11 plus 7 will be 18, and you can use it similarly with minus as well. So that's how it works. So since matrices is not just tables, right? It's supposed to be represented by square brackets. So that is how it works. That's how matrix looks like. On to the main content, right? So we've been covering 4 basic syntax for NumPy. Firstly, NumPy.zeros. So you need to define the rows and columns of the zeros matrix that you want to create, and the data type as well. So for example, in this place, I've given data type to be float. You can use integer as well, but like for demonstration purposes, I'm just going to put it as float. So you might be wondering what the order is equals to C means. So order is equals to C basically means which thing you'll be prioritizing, rows or columns. So is it like, so whether the multi-dimensional data will be stored in a column major format or a row major format. So a column major format will be order F, a row major format will be C. So honestly, a data type and order are optional right here, at the moment, but it will be more useful during VStack or concatenation, etc., and flattening. So, but yeah, this is a syntax that applies to the zeros matrix, and this applies to the ones matrix as well. So if you give the rows and columns, it will create a ones matrix with that particular number of rows and columns. The third one is an np.empty. So this creates a NumPy array that has values inside and can be edited by the user later. So this function creates an array without initializing its values, okay? So it allocates memory for the array, but it does not set values for it. For example, 1, 2, 3, 4, etc. So it doesn't set that values for you. So the content of the array is undefined and may contain any arbitrary value. It's faster than some of the other array routines like np.zeros or np.ones that we learned just now, because it doesn't initialize the values, right? So when you're going to put in data set, you're going to have data, right? It will just it's more likely to have the data that you already want inside. So yeah, so how is this different from np.array? So the main difference is that np.array creates an uninitialized array, while np.array explicitly creates an empty array with no elements. So np.array is an empty array, completely empty, whereas np.empty creates just random values of sorts. So what are the benefits of this? Why am I even learning to use np.zeros or np.ones? Like, where am I even gonna use it if I can just create an empty array and insert elements in? So firstly, this will be used in machine learning, yes, and also masking and filtering. So in data analysis and signal processing, right, arrays initialized with zeros or ones can be used as masks or filters to perform operations selectively on certain elements of the arrays. And secondly, image processing. So in image processing tasks, right, initializing arrays with zeros or ones can be useful for creating masks, defining regions of interest, or setting up initial conditions for algorithms, like we'll be learning later. Thirdly, it also allows memory allocation. So pre-allocating arrays with zeros or ones can be more memory efficient than dynamically resizing during computation, especially when dealing with large data sets. So moving on, we're going to learn about np.arrange. So it is a NumPy function used to create arrays with regularly spaced values within a specified range. So it's similar to Python's built-in range function, but it returns an array instead of a list. So this syntax goes like this: np.arrange, first number, last number, and step size. So which is basically what is step size is basically the difference between each term in between. But where there's no specifics, it will just assume that it to be the number of elements where the step size is 1. And since it's zero-based indexing, it will just start with 0. Okay, so take it like an arithmetic progression you learn in math, where you say, oh, there's going to be, it increases by 2 every single element onwards in that progression. So looking at np.arrange, right, 292, you'll realize that the last number cannot be 9, right? Because it has to be an even number. It starts with 2, 4, 6, 8. So 9 cannot be number that's involved. So we just stop at 8 with an increment of 2, that's all. So since 10 cannot be reached. So an alternative to this would be linspace, where it would result in floats, and the num equals to 5 means 5 elements in total, where the step size is not specified. So this will be useful when you don't know what the step size will be. So you want to divide this, for example, 100 numbers into 50 different, you want to have 50 different like sections of sort. You don't know what's the step size. So it will automatically create your step size for you. And so in this case, it will be like 2.5, 2.5, 2.5. So if you don't know the step size, it will just calculate for you and give you the numbers. So now I'm going to go through 2 other pretty cool syntax. which is np.full, basically would create a constant array of shape 2, 2, that is 2 columns and 2 rows with number 7. And basically np.zeros are and ones for another number. So, and another one would be np.I, which would be creating an identity matrix, like a crash course Sec 4 lesson. Okay, so identity matrix is basically a matrix where where all in the diagonal you would have ones. For example, here in this part of the slide, where's my cursor? Okay, so you would see that the ones are in the diagonals, 1, 1, 1, 1, 1, 1, 1, 1. So the rest of the slots for the matrices are zeros. So that is an identity matrix. And where is this used? An identity matrix is used when you want to find the inverse of a matrix. So if there's a particular matrix, there's also an inverse of the matrix. So A times A minus 1, I mean A to the power of negative 1, just the inverse, okay, will result in an identity matrix. That's when you know that they're inverses of each other. As much as I want to use the board right now, I understand that you won't be able to view it. So I'm going to explain this as much as I can via speaking. So firstly, imagine that we are going to, okay, in this A, right, you're going to have 4, 3, 3, 2. Imagine the first 4, this one will be A, the first 3 would be B, the other 3 and the bottom row would be C, and the 2 would be D. So if you want to find the determinant, you have to find the determinant to find the inverse of a matrix, right? So it's 1 over AD minus BC. So in this case, 4 times 2 is 8, minus BC will be 3 times 3, so that's 9. 8 minus 9 will be negative 9. So 1 over AD minus BC will be 1 over negative 9, so negative 1 over 9 up. And then when you want to find the inverse of a matrix, right, you just flip diagonally. So for example, A would move to B, A will move to D, and D will move to A, B will move to C, C will move to B, but C and B will be multiplied by a negative number, which is negative 1, multiplied by negative 1. And then if you want to find the inverse, then you just multiply the determinant and that matrix, the inverse matrix that we just found, and then you would find the inverse of a matrix. So we will learn a little more about matrix multiplication later when Shengsen goes through it, but this is basically how inverse relationship works. So moving on to slicing. Slicing in NumPy arrays is similar to Python lists in the sense that the index starts with 0 and the index before the colon is included, whereas the index after the colon is excluded in slicing. So you can have a look at it to quickly refresh your memory, like sourcing the element 1, that is the 0th index row, and 0th index column would be 0, 0. If you'd like to source the element till the 2nd index row, but exclude it, you would have a result from 1 to 6, 1, 2, 3, 4, 5, 6. Similarly, when you enter print matrix and place 4 and then a colon, it will result in 5, 6, 7 being given to you. This is applied to negative slicings as well, where the last element is seen as 0, the second element is negative 1, so on and so forth. So in that case, it will count backwards from the end of the array to the index which corresponds to the first parameter entered. So we basically follow through with what we learned in Python listing on negative index. So for example, in -2 to -1 slicing, right? In -2 to -1 slicing, right? It will result in 1, 2, 3, 4, 5, 6 as a result. And it is really important to make sure that the larger number is after the colon so that it won't result in a null array, because except in the case where the step size is negative. So you can try running the cells in the Colab and try to understand all the questions are in the Colab. So some of them you may not see on the slides. So please have a look at the Colab. So one thing I want you all to take note of is the difference between these two pieces of code. Can I have perhaps anyone say in the poll what the difference here is? The poll will be launched in a second. Give me a second. Give me a second. So we have launched the poll in the chat, so have a look at it. Can you all vote for it? What is the difference? Okay, I see the votes coming in already. So, yep, there is a comma in the print matrix. I understand some of you all don't know what's the difference between that. But what is the true difference? It is the results. So the code on the left slices the matrix along the rows and selects the entire second row, basically index 1, remember, 0, 1, resulting in a one-dimensional array containing all the elements from the second row of the matrix. However, for the code chunk on the right, this slices the matrix along the rows, starting from the second row until the end of the matrix. So this selects all the rows starting from the second matrix, which is second and third matrix, and this results in a submatrix containing all rows except for the first one. Okay, so now to move on to simpler parts. So attributes of an array. Given the above array, by using dot size, you'll be able to find the number of elements in the array. In this case, will be 5 because it's 0, 1, 2, 3, 4. Okay? So using dot n-dime, you'll be able to find the number of dimensions. This is just a one-dimensional array, so it's 1. Remember I had a pre-content quiz earlier. I'm sure you all can recall what it is. So the syntax follows: number of planes, number of rows, number of columns, right? Basically the tuple of the integers that indicate the size of the array in each dimension. So that's how you make use, that will be the result for a.shape. A few other useful ones will be .dtype, which would allow you to find data type of that array, and .stype, which will allow you to convert an array from one data type to another. Say in this case, from an integer to a float, okay? So now moving on to some array manipulation. Remember earlier I said row major would be denoted by C and column major would be denoted by F. This is where it comes in handy, okay? So when you are flattening a 2D array, it becomes a 1D array. If it is a row major one, it would be 1, 2, 3, 4. Whereas if it is a column major one, it will be 1, 3, 2, 4, because it follows a column order and there's one with a row order. So why I did not enter C is because the default for this order would be C. It will always try to follow the row major. Okay, so yeah. So as for sorting, right? You'll be able to sort along columns or rows too, but you shouldn't use column major or like row major because but access 0 and 1 here, because sort will see it as a string, which is contradictory to it needing to be an integer. Okay. So as for reshape, we can simply reshape an array into, say, a 4-row, 3-column matrix. You can reshape it into a 3D array by entering the parameters of the shape of the matrix, etc. So I know it is a little content heavy, so just bear with me a little longer. I'm almost done, okay? So the next one would be np.hstack. So it basically stacks arrays horizontally, whereas np.bstack stacks arrays vertically. So as you can see in the code below, right, there is a square bracket around every term. There are 6 elements in total, and they are being stacked vertically. Okay? Moving on to concatenation. Imagine you're concatenating two 1D arrays. You'll basically be combining them into one 1D array. However, when you're concatenating one 2D array and another 1D array, the greater degree takes preference, which is 2D array. So you'll combine to create a 2D array that is being stacked vertically. Okay? I keep saying okay. Moving on to concatenation. Imagine you're moving on to combining sort, concatenate, and reshape. Okay, so because you want to know how these all work together, right? So using sort, you can sort along the columns or rows, then concatenate vertically and reshape it into it becoming a 3 rows and 4 columns matrix. So you all can try it out in your collab. And at this point, if anyone is confused, please do put it in the Discord channel so that we can have a look at it a bit later. So at this moment, you all can process information for the next 5 minutes. We'll get back to this as soon as possible. Is the Discord moving? If you all have any questions right now, we will be answering it in the chat. So feel free to. Okay. Assuming you all don't have any questions, right? You know what? Let's cut your break. Moving on. This is what teachers do. Y'all will have to learn it someday. So as we are done with sorting, concatenating, and reshaping, we'll be moving on to iteration. So we can also iterate through NumPy arrays like we do in Python lists. And a for loop will help us iterate through elements in the array, which includes a nested array. And for 2D or multidimensional arrays, we will get a 1D array as the element when we iterate through the array. So we can use nested loops to iterate through multidimensional arrays, or we can use np.nditter to iterate through all elements, including nested elements in a multidimensional array. And also np.nditter, right, can also write into the element while iterating through it, but we will not cover that today. Yeah. So moving on, Shamsun will be sharing about NumPy functions, but before that, yeah, try to process this information real quick. 1 minute. Shamsun will be also sending the slides now into the chat so that you all have better understanding, and I won't have to just keep clicking slides so that you all can have a read at it again. I mean, most of the things are available on the Colab as well, so feel free to have a look at the Colab and run them so that you have some form of exploration as well.
Okay, so firstly, we apologize for the speed because we do have quite a lot of content, especially since we're covering 2 Python libraries in 3 hours, which is something we have never done before. And we will try to slow down for the next few sections so that you're better able to understand it. So next, we'll be moving on to NumPy functions. And our first function will be matrix multiplication. So as some of you might have learned in eMath, if you're Sec 4, we can actually perform operations on matrices. And as you know, in NumPy, we're able to make 2D arrays, which are similar to our matrices. Thus, we can also perform this matrix operation in NumPy also. For matrix addition and subtraction, it's quite straightforward. You can use the plus and minus symbol to get the difference in values between 2 matrices. As for matrix multiplication, it's a bit more complicated. But let's say you wish to multiply these 2 matrices. To ensure that you're able to have a successful matrix multiplication, we firstly have to check if the column of the first matrix and the row of the second matrix are the same. By using this data, as you can see, you can also find the order of the final matrix that you're going to get. So firstly, to get our first value in our new matrix, we have to take the first row multiplied by each value within the first column of the second matrix. In this case, it will be 1 times 1, and we'll plus 2 times 4, and we'll add 3 times 8. With that, it will give us 33. We'll also repeat for the other parts of the matrix. In this case, it will take 1 times 3 plus 2 times 9 plus 3 times 5, which will give us 36. And similarly for the second row, first column, and the second row, second column. So we can actually perform this in NumPy through the function .matMul. And what we can do is, over here we have these two matrices, and we can just input the two of them separated by a comma in the matMul brackets. This will allow us to get the results as you can see in the Google Colab. Next, we'll be moving on to inverse. This is sort of an additional information after what Shivani have shared in her previous section just now. But we can perform inverse of matrices in NumPy through the function .linl.inv and the matrix. So this is just the formula for it. And these are the math formulas to tell if a matrix is invertible. So on the left, I'll say it's a more simplified version where you just take the diagonals minus the other diagonals. And for the one on the right, how you can see it is that the square that I have outlined right now would be the D value for that corresponds to the image on the left. And these two will be the D values for A2. And this is how we'll derive the formula for this. As for transpositions, what we're doing is just basically switching the axis of the 2D arrays to return an array with the swap axis. So for example, by adding a .t behind our new array, you'll see that the 3 and 2 have swapped places, and our final matrix will be 1, 3, and 2, 4. Lastly, this is quite a bit more advanced, but we'll be talking more about broadcasting. So broadcasting refers to how NumPy treats arrays of different dimensions during arithmetic operations. Over here, we can see that arrays have different dimensions from 1D, and it can go all the way to 5D. And as I've mentioned previously in matrix multiplication, the column of the first matrix and the row of the second matrix, they have to be the same for matrix multiplication to happen. So what broadcasting does is it basically handles all the cases where we aren't able to use that. So let's start with a simple example to illustrate this. In this situation, we can see that multiplying x by 7 is the same as multiplying x by an array of 7. The array of 7 would be denoted by y. This is possible because of broadcasting, which you can think of as stretching the value to form an array of the appropriate size. So what if we have multiple dimensions? For example, in this case, we have this 2D and 1D array. How can we use broadcasting? So over here, we'll take the array with the smaller number of dimensions, which in this case will be y, and it will multiply throughout every row of x. So in this case, how it got 7, 6, and 27 in the output would be by taking 1, 2, and 3 in the first row of x times 7, 8, and 9. Similarly, as we move down the rows, 4, 5, and 6 times 7, 8, and 9, it will give us 28, 40, and 54. And similarly for the last row also. So we do have some rules to follow if we want to use broadcasting also. Firstly, if the two arrays differ in their number of dimensions, the shape of the one with the fewer dimension, for example, the y over here, it will be padded with ones on this leading left side. leading. So what it means is just on the left side of y, they will add more ones to it to be able to fit the shape of x. And next, if our shapes don't match in any direction. Oh, sorry. And lastly, if there's a size mismatch in any dimensions, and neither of the size is equivalent to 1, then we won't be able to perform broadcasting on these. We also have other examples that can show how broadcasting works. And this will be the result for the previous one. And now we'll be moving on to our NumPy mini project. We currently have allocated 40 minutes left for our last section for NumPy. And you can find the project at the last part of our Google Colab, as there's quite a lot of, I'll say, sections in the project. We'll currently give you 15 minutes. And if we do need an extension, I'll check in I'll send a poll and we'll extend it by around 5 to 10 minutes, depending on where y'all are at. So now you can go back and refer to the slides, as most of the solutions can be found using the syntax taught by Shivani. And we'll find you at 405. Hi everyone. I've sent a poll into the Google Meet right now, and if y'all can just vote on which section y'all at. If most of the people are at like 5 or below, I'll extend by 10 minutes. Thank you. 5 and below. Can, based on the results on the poll, we'll be extending by 10 minutes. And for those who are like at 7 to 9, if y'all complete early, y'all can just take a break first. Yeah, thank you.
So we will convene back at 4:17.
Okay, Ken, now I'll be going through the solution for this exercise. Wait. Okay, Ken. So firstly, this is just the values that I've chosen for the students' grades. And so what I did was I printed out each results for every single part, and I'll show you the final results later. And so for part two, the question asked for you to flatten it, and how you could do it is, for me, I created a new variable to store the flattened scores, and I use dot flatten. And do take note that instead of using np dot flatten etc., you have to use the variable name of the NumPy array, which in this case would be scores for me. And for part three, the question asks for you to sort the array in ascending order, and what you can do is use dot sort the NumPy array name, which is scores. Actually, you won't need this, but it's just for clarity's sake on my end. And for the second part of the part three, you also need to sort it in descending order. And in this case, it's the same. It's the same. I'll say statement, but you add this colon -1 to reverse everything. As for the transposition part, I've also created a new variable in this case, and I use the NumPy array .t behind it. For part 5, how you flip the the array vertically along axis 0, which would be the y-axis, would be you use dot flip and the NumPy array name. And because it's usually set to default axis 0, you won't need to put this, but just to make it clearer to us and also the program, I just added it here. And if you want to flip it horizontally, you can use the same statement, but you just change axis equals to 1, because 1 represents the x-axis. As for part 6, how you reshape the array to a new shape, which in this case we want 2 rows and 6 columns. What we can do is we can use dot reshape and input our NumPy array and also our new shape that we want this array to form into, encapsulated by these brackets over here. Then for part 7, we want to concatenate the new class scores to our current existing score. So this is like a new set of class scores that I created. And then how you concatenate this one, and oh yes, I'm presenting. Are you able to see? Oh, okay, wait, let me try to reshare. Is it better now? Wait, give it a moment. Oh yeah, is it better now? Yeah. If you're not able to see the screen, we'll have this whole workshop will be recorded and uploaded so you can view back, and we'll also send you our speaker's version code for you to refer. Oh, okay, Ken, that's good to hear. And after concatenation, we also have horizontal stacking, and this can be done through .hstack. We want to stack our original scores and our new array of scores. In this case, I titled it extra subject scores. And you can add them together via a comma. For vertical stacking, it's the same except you use vstack instead of hstack. For the second last part 8, we want to find the average score of each subject. And in this case, I use .mean. and mean is just like another word for average. And we also want to base this column-wise. So I use axis equals to 0. And for the next part of part A, we also have to find the total score for each student. And this is based on the rows. So in this case, I use dot sum and also axis equals to 1 to calculate based on the x-axis, which is also known as horizontal. Then lastly, for part 8 section, we also have to find the number of students whose scores in the science, aka column 1, are higher than their score in math, which is column 0. Column 0 would mean like the first column, and column 1 would be the second column. So in this case, what we do is we take the science column, which can be denoted by this one, and we use the Boolean greater than. And we compare with the math column. And afterwards, it will print out a list of like false, true, and we'll see that later. For part 9, we have to create a new column by summing all the scores in all subjects for each student. And how we can do that is by using dot sum. And because each rows have different subjects for one student, we will have to sum it out based on horizontal methods. And for part 10, we have the last two segments, which will be to sort the students based on their total score, which is the one that we created just now. And we have to do it in descending order. So what we have to do is use np.argsort after putting like this square brackets next to the array that you want to sort. And we add, and this is the column that we're basing it on. And this just means to sort it in descending order as we reverse the whole entire array. And for this, we have to group the data and subject and calculate the average score, which we have done before previously using dot mean. And this will be how it will look like for each segment. So initial scores, these are the first scores I created. The flattened score would look like this. The sorted in ascending order would look like this. And descending order would be something like this. For the transpose score, it will look something like this, and it's in a 2D array. And for flip scores, we have flipped this to, this is like 3 rows, 4 columns to 4 rows, 3 columns. And we also flipped it horizontally. Then another section asks us to reshape. And after reshaping this, we'll get something like this. And by adding the concatenating 2 scores together, you'll see that the other score is at the bottom. And for this one, we added it to the right side. That for this one, I only added 1 new row, so it will look something like this. For the average score, it can be denoted in this array. And this was the one, this is the Boolean one, where it compared the science students to the math student scores. And this is the total scores column, followed by sorting each student based on their total scores. And lastly, this is like the average score for each subject. Yeah, it's mainly just using the different syntax found within the slides. And now I'll be passing the time to Shivani, and we'll be moving on to pandas. And in the meanwhile, we can give you a short break because I think I explained faster than I expected. So you can have until 4:30 to either type any questions into the Discord chat, and do take note, we'll only be able to accept questions through Discord as we are not able to use Q&A on Google Meet. And if you also want to like grab some snacks and water, you can also do so in the next 4 minutes. And we'll see you at 4:30.
Before we begin, please do remember to duplicate the Pandas collab that we sent earlier in both the chat and as well as the Discord. So I hope everyone is back. I'm hoping everyone is back. So moving on to the second half of the workshop, pandas. This is a bit more fun. I'm pretty sure it's going to be more lively. Yes, the age-old joke, pandas. Sorry, like really, we cannot think of a better joke, okay? Because like our love for computing really damaged our humor. Yep. So pandas is a Python library most widely used for data science and data analysis and machine learning tasks also. So basically to work with data sets, and is designed to make working with structured data sets, data easy and intuitive. So it has functions for like analyzing, cleaning, exploring, and manipulating data. And it is actually built on top of NumPy. That's why we have our workshop of pandas and NumPy. So why should you vote for the pandas? Firstly, it provides flexible data structures because firstly, it can provide like adaptable structures, right? So with powerful instruments for data indexing, selecting, and manipulating, which sidesteps the need for complex programming methods. And you can easily convert like CSV, Excel, SQL databases into data frames. And when you're done analyzing the data and extracting your insights, whatever, you can just easily export your data frame back to that familiar format that you initially used. And it makes it so much easier to share your discoveries and incorporate them into other software. Secondly, it enhances performances with big data sets. So the thing is, Pandas excels in managing big data sets, okay? So it streamlines the tasks such as sorting, filtering, and merging data sets swiftly through like vectorized operations. And unlike the conventional Python approach of processing data item by item in a slower loop, Pandas handles entire data sets simultaneously, and thereby saving time and reducing the complexity of large-scale data projects. So thirdly, it smoothly integrates with other Python libraries. So Pandas works in harmony with so many other Python libraries, allowing users to draw on the strengths of other diverse libraries and each of its strengths. So for example, its compatibility with NumPy, SciPy for scientific computing, scikit-learn for machine learning, and even like data visualization through Seaborn and Matplotlib, which you all will be learning in the next workshop. And there's so much that Pandas offers, in the sense that it acts as a connective tissue to other libraries and streamlines the data science process. It also it has a very intuitive and readable design. So it follows our natural language of speaking. So in making it easier to understand, and even for beginners. And then it also streamlines data cleaning and wrangling, because data scientists actually spend 80% of their time on trying to remove all those null data, bad data. And so we want to reduce that time that they spend on it. So Pandas really streamlines these essential tasks by detecting and rectifying these errors, and ensures their accuracy and dependability. So also, they have such a wide supporter base, so that's why you should vote for Pandas. Now that I'm done with my election campaign, right? So you should also vote for me for the next president of Singapore, and I'll make sure Pandas are throughout Singapore, because they make your life so much easier, and you can cuddle them all you want. Okay, so one way to what does Pandas allow you to do? It analyzes big data, so it makes analysis or conclusion based on statistical theories, and it also cleans up big, messy data sets, making them readable and relevant. So in the sense that you'll be able to remove null data, so you'll be able to format the right data, you'll be able to replace data, etc. And then there are other capabilities that you can see in the image in the screen, and you can spend about 30 seconds to have a look at it. Okay, so moving on, starting off with how to sign the petition to have Pandas and how to make me the president of Singapore. Firstly, have import Pandas as PD. So import is basically how you import a particular library. And SPD basically means that your PD is a short form of Pandas. You know, when you're typing away, like you're writing a code and whatnot, it's gonna take more time if you want to type pandas dot something, pandas dot something. So PD is just a short form for you to use, and that's kind of like the standard that we use. But if you want to use something else, like, I don't know, man, PDS, PAD, I don't know, we'll do whatever you want. Up to you. But this just makes life easier. And since we are using Google Colab, we just have to put import pandas as PD. But if you're going to use other stuff like Jupyter Notebook, VS Code, whatnot, you will have to install pandas. So what you would have to do is pip install pandas. But Google Colab already provides it to us, so we just use import pandas as PD. So Pandas has two things, series and data frames. So series is where it's a one-dimensional label array that can hold any data, be it dictionary, lists, and whatnot. And it can be seen as a column in Excel. What it has here is an index and data. That's what a series has. And however, it is limited to only 2 columns. Okay, so so in this case, you're gonna have a Pandas series, right? So how would you create one? Series is equals to pd.series, and then you have a dictionary, for example. Here, there's a dictionary here. Name is equals to Tom, school is Temasek Junior College, age is 18, conference is March. So you print the series. The result would be this tiny table of sorts where you'll be able to see name, Tom, school, Temasek Junior College, etc. So in the place where you don't give them a particular column to follow, it'll just default it to 0, 1, 2, which is our indexing, right? So we can just put it as series is equals to pd.series and just have a list of names, and we'll just use 0, 1, 2 as the key instead. So because when you have dictionaries, right, you're going to have key and value pairs. So the key will become the first column, and the value will become the second column, right? But where you don't have a key, you're just going to have a list, for example, then you can just use the indexes as a key, and the value would be whatever value you've given in the list. Moving on to data frame. So remember how previously I said a series can only have 2 columns, right? Pandas data frames can have more. And for example, here you can see that it has 4 columns and 4 rows. So how do you create a data frame in the first place? Firstly, if you already have a CSV, then you put df is equals to pd.read CSV and put the file path there. Or for example, in Google Colab, you just have to upload it into downloads, which is present on if it looks like a file section, then you click on the file, then you'll be able to upload. We don't have a CSV to use today. We'll be primarily be using the second method. I mean, here you also can make use of Excel, by the way. So second method, which is data is equals to whatever you have, and then you put pd.dataframe data. So this will be the syntax for how to load your data into a data frame. So unlike a series, do remember that the key for the dictionary becomes the header. So you will have an index here, but this would be the main one. Understand? So now I'll be passing the time on to Shamsin to take care of algorithms.
Oh, okay. So firstly, about algorithms, you might be thinking right now, don't we have another workshop happening on this Wednesday titled Data Structure and Algorithm, which, by the way, you should also sign up for if you haven't. So actually, for Pandas, we also have our own set of algorithms that follows the Pandas syntax, and I'll be going through that. But before that, here's some Pandas syntax to take note of because it comes out quite often in the following code that I'll show you. So firstly, .head is just to print out either a certain number of rows you want, or if you leave X blank, then it will print out all the rows. And if you only want to access one column in the data frame, one or two columns, you can just use df is just short form for data frame. This is the name I named my data frame. And you can put double square brackets, and these two are the column names. And then I'll print them out using .head. So firstly, we'll be teaching you sorting. So for sorting is basically just to sort your data to make it look a bit more clean. And you can sort them, you can either sort like one column, or like multiple columns concurrently. We also have this option where you can like choose, if you have done competitive programming before, you might have heard of these, but these are just some of the sorting algorithms like quicksort, merge sort, and heap sort that you can also choose to carry out sorting in Pandas. So let's say this is your data set. You have the semester, the subject, and the different students' grades for each semester and subject. Yeah. So for one column sorting, all you have to do is use .sort underscore values, and this is the column name, as you can see over here. And I want it to be ascending order, thus ascending equals to true. Then I print it out, which will give me this. And as you can see, student A is sorted from 85 to 92, which is in ascending order. Then for multi-column sorting, just do take note that every time you want to sort like more than one row or more than one column at the same time, you have to put square brackets and put the two or however many values you want inside, and you separate them with a comma. In this case, I want to sort student A and B's column. And the result will be this. If you look at the previous one versus this, you'll realize the results are the exact same thing. Why does that happen? So one way you could think about it is you can take each row as sort of, I'll say, a list. Then as you sort student A's column, each list within each row will also move along with the grades to their new positions. Thus, only when there are like two exact same values within student A's column, for example, if this wasn't 90, this was 88, then it will go to student B's column and use these two values to see which one should be placed on top of the other. And this is just the point form of the explanation. Then, as mentioned before, there's also something called a custom algorithm sorting, where you can choose your own sorting algorithm that you want. And how you can implement it is using a comma kind equals to the sorting algorithm. For most cases, there wouldn't really be a difference in your results, as you'll still get the same results. The only difference is that maybe if you have like larger data sets, some Some sorting methods will be more efficient and faster than the others, but the difference is quite slight, so we won't notice it mostly. Next, here I have another data frame that we have initialized. But wait, what is this? What is NaN? So NaN is basically there's like no value at that position. But how are we supposed to sort this? Is it even possible? Actually, we can do that in pandas because, as Shivani mentioned, pandas should rule the world. And what we can do is use a comma, NA, which would be like no value, and underscore position equals to first. So what I've done here is I filtered out all the non-values and put them at the top. The rest will still be sorted. And next session we'll be moving on, we'll be searching. And to celebrate that we have moved on to a new section, here's a new data frame. And the only difference is that they are now employed and I gave them jobs. So here are some syntax on how to access columns. As mentioned in the first slide for algorithms, you can just use the square brackets and the column name and the head to print them out. At the bottom, it will also tell you like the name of the column you have printed out and the data type, which in this case would be integer. And to access different rows, for example, I want to access this row. All you have to do is use .iloc and 1. It will refer to the second row, which will be Bob, and he's 22, and he's a lawyer. And to filter rows, you can use .loc. So the main difference between iloc and loc would be iloc is more for if you want to find positions and you can like express them using a numerical value. For example, in this case, it will be 1. But for loc, it's usually more for like column names, row names, where you use more of a text-based method to find the values that you want within this data frame. So what I've done to filter out would be, I want to find all the people who are older than 25 years old. And this is the column, and I've used the Boolean comparator greater than 25. And it shows me Alice and Charlie, who are the only ones older than 25. You can also use equals if you want to find a specific, for example, in this case, I want to find a specific job and it will be lawyer. And it will print out all those people who have lawyer as their job, which in this case is only Bob. You can also filter multiple things at once. In this case, I wanted to find people who are a lawyer and also people whose age equals to 22. In this case, my output is similar to the last one, also Bob, because he's also age 22. And if you do want to filter out multiple rows in a column, what you can do is you create a new list with the two row names that you want to filter. Then you can use .loc. This is a column name that you want to filter, and you can use .isin. And then you add the list of the two rows. Afterwards, you can use .head to print out the results. In this case, I got Alice and Charlie, as they are both a doctor and programmer. Okay. So for indexing, why do we usually use indexing in pandas? Let's say you have this amazing data frame versus this. Obviously, the second one is easier to read and understand compared to this one, as this is all over the place. So how we can implement multi-indexing would be, let's say I have this list with city names and also the different years, and you can use .multi-index and .from arrays. And this array will correspond to this whole entire chunk here, and names will be like sort of the column names that I want to arrange them by. In this case, I want to arrange them by city and by year. So our output will give us this multi-index where this will be the city column and this will be the year column. And they sorted it out by grouping New York and Chicago. This will be our final data frame. In the Colab, I have added on these two parts. And I've also turned previously this multi-index to a data frame. And that's why it looks like this. So if we do want to access specific values in this data frame over here, what you can do is use .log and use a bracket, the column, the name of the city in the column, and also the year that you want to find. In this case, it'll give me that New York's temperature and rainfall in 2021 are 30 and 100 respectively, which corresponds to this one. But maybe I just want to access all the values under Chicago. So what you can do is just to put Chicago in the square brackets over here and like not have anything afterwards. And it will print out both the years and the data for temperature and rainfall. Next, we'll be moving on to merging. So let's say you want to merge two different data frames together. You can use .merge. So left will indicate the name of your first data frame and right will be the name of your second data frame, and you want to merge left and right together. So on will just be, for example, if there's like a common column name between left and right, you can switch none to that column name, and you'll merge the values merge your values on that column. And how we have like different types of merge, for example, left will be in merge, everything from the left will be included, but only the common columns in the right will be included, and similarly for right. So for this section, I've initialized two data frames for this purpose. Our first one will have Alice, Mary, and John, and second one will have Sally, Peter, and Mickey with their ages over here. And now I want to merge these two data frames together. So I could use df1, which is our first data frame, merge with df2, which is our second data frame. And this will be our output. As you have realized, we get an empty data frame. And why is that? So over here, these are the people that we have, right? Alice, Mary, and John for the first one, and Sally, Peter, and Mickey for the second one. You do realize there's like no common name between both of them. And for merging, how it works is that only when it has like there's like any commonalities between these two data frames, then it'll print that commonality out. And since it's like nothing in this sector, we get an empty data frame. Next, we'll also be moving on to concatenation. Concatenation is quite similar to merge, but I'm so sorry. I have to edit this. But what it does is basically it adds all the items from data frame 1 and all the items from data frame 2 together. OBJS is basically the different data frames that you have and you want to concatenate together. And this axis, as Shivani have taught in NumPy earlier, you can either merge it vertically or horizontally. And for this, we'll also be using the same two data frames again. And this is the correct syntax, .concat. And as usual, when we have more than one things that we want to merge together, we use a square bracket, yeah. And usually, if you don't add the axis behind, it will assume for it to be merged vertically, which is what happens in this case. Alice, Mary, and John, then Sally, Peter, and Mickey below it. And if we do want to merge it horizontally, you can use axis equals to 1. And now the values will be next to it. And now I'll be passing the time back to Shivani to explain more on data cleaning.
Okay, so back to me on data cleaning. This is where you get to apply all your Pandas skills in real life. So what is data cleaning? Data cleaning basically means fixing your bad data in a data set. And as I said earlier, bad data could be empty cells, null values, data in wrong format, wrong data, duplicates, etc. So the main 4 things that we'll be looking at today will be these 4. So having a look at this data set, please join the Mentimeter code at the right-hand corner of the screen, and please input what is wrong with this data set. You all can have a look at the Mentimeter code, and please join the Mentimeter. I'm hoping that some answers will start streaming in. Yep, please answer here. I would appreciate if you could do some exercises. It's pretty simple. You can see where exactly the error is. Okay, some missing data. Ken, are there any other errors? Okay, NaN. NaN is not on top, it's not an error, don't worry. Missing some data not filled, yes. That is NaN. Duplicate, yes, great job. Missing or wrong data? Missing data, kind of. Duplicates, null values. Okay. Thank you for your responses. I'm just going to move back to the slides now. Okay, NaN in date and calories, outlier and duration. That's great, yes. Okay. So firstly, we see a an empty values. So there are 3 empty values, one on row 22, one on row 18, and one on row 28. So they are indicated by NaN, which is, as Shengsen said earlier, they are values that are not available, also known as null values. Here we have a wrong format. You see every other date is a string. However, this is not a string. That it is not within quotes. So that is one error. Third error is there's wrong data. The duration is 450. That means 9 hours there. I'm pretty sure no one exercises for 9 hours. I'm hoping no one does. If not, you're training yourself. This could imply that since everyone else's input is 30, 45, and 60, this person could have meant 45 but accidentally typed it as 450. Okay? And there's also duplicate data on row 11 and 12. And we can remove it because in large data sets, right, it doesn't really matter at some particular point if you're going to remove some duplicate data. So firstly, let's start out with null values. How are we going to tackle null values? Firstly, remove entire rows. So here you can see the data set, and then what it will do is remove these entire rows. For example, 22 is not here anymore, 18 is not here anymore, and 28 is also not here anymore. So that's what .drop NA will mean. It will drop entire rows which have not null values. Can you spot the difference between these two? Can I have text in the chat, in the Mentimeter again? What is the error? Sorry, not what is a reply in the chat. What is the difference here? I would appreciate some answers. I'll go back to the screen so I can see. Differences, guys. Yes. I'll give you all another minute to enter the difference and what they mean. I'm hoping everyone is typing away. Yeah, 6654. The code is 66547533 if you all missed it. 7553. Yeah. If you missed it. So I would appreciate some answers. Yes. Okay, you know what? Assuming that y'all don't know, it's fine. I'll just tell y'all what the answer is. But y'all have disappointed me. Okay, so the difference is in place is equals to true. What this actually means is that when in place is equals to true, it directly changes the initial data frame that is given to you. That means it's altered forever, and you will have to run the initial data again if you want to edit whatever is in the original data frame. However, on the left, right, it just creates another data frame which you can edit. You have edited to have to drop a particular row, for example. Okay, so moving on. You can also replace the empty values because entirely deleting rows may mean that you're losing data. So in that case, you can fill it in with a particular integer, for example, here as 130, and change the initial data frame itself. Or you could change this in a particular column. So for example, if you don't want to fill this 130 into a date column, why would you want to have 130 as a date? The date is fine there. You would want to change the calories section, for example, the column. Then you would define the calorie. I mean, you would add the calories section here and then fill in the data there. Well, you can't just randomly add data, right? You can't just say, oh, it's going to be 130. I mean, does it have any value as a value itself? No, it doesn't. So what would you want to do? You probably want to get a data that's more standardized, right? So there you'll make use of mean. Okay. So when you're making use of mean, you get a value, and you can value of the mean value of all the calories that are available in all the other datas, and then you get the mean of it, and then you substitute it into the NaN place where in the calories column. You can also work with median, which is the middle value, which kind of like makes it less skewed if some mean values are too high. And you can also make use of mode, which is the most reoccurring number, for example. But mode has a slightly different syntax now. So mean and median is what we are teaching today. So mode is, I think it should be available on your Colab as well. You can run it. So thirdly, wrong format. So to tackle wrong format, you can convert it into the correct format. So for example, if it's not a string, right? By using this, you would convert it to a date format. So NaN becomes NAT. So by converting it to NAT, what you're saying is this is a time, but it's null value of sorts. So we're going to change the null value into dropping the rows. Okay? After identifying it to the correct format, like here 26 has changed. That's great. It has become a string, but 22 hasn't changed. So you can drop the rows using the previous method of drop NA. Yeah. Moving on to wrong data. So when you have wrong data, you can just replace the values with whatever Shamsin has taught you earlier with .log. So by using .log, you have to mention which row is the error in, which column is the error in, and you change that particular value to 45. But then you can't just know where every single value is, right? Every single error value is, you wouldn't know. So what you would do is for x in df.index, if the duration is larger than 120, change it to 120. Because remember how we had 450? That's not possible, right? It's wrong data. So what we're trying to do is change it to 120 instead. But we won't really know whether other data are more than 120, right? If it's a large data set. In that case, we just make use of a for loop and have this if statement to convert that 450 or any other number larger than 120 into 120 instead. Then you can also remove rows. For x in this particular range, you can just drop the entire row. Okay, so why would you use this? You'll only use this when you do not need a substitute value. You would only replace when you don't want to substitute anything and it doesn't really value add to your analysis. Okay? So next we have duplicate data. So for duplicate data, right, you can first discover where the data, the duplicate data is. For example, this one, right? This is where you will find, this will allow you to find your duplicate data. So you have false, 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 and then you see, oh, 12 is 12 is supposed to be true, and oh, okay, it's printed because of that. Okay. So 12 is duplicated, so you would have to remove it, okay? And then you can just discover and remove it using this. Yeah. So the duplicated data, 12, will be removed. Sorry. And now we'll be moving on to the mini project. The mini project is available in the Colab. I have uploaded the necessary instructions. Hold on a second. You are seeing my answers. Hold on. Yes, this will be the project. You all can spend about 25 minutes on this because I know that it can take a bit of time because you're going to be collaborating making use of both your NumPy knowledge and your Pandas knowledge. So yeah, you can take the next 25 minutes until 5:30 to finish this project. Please make a duplicate copy of this notebook in your own drive so that you can edit it. Yeah. Just to let you all know, right, you already have access to the data that you'll need to use, which is data is equals to movie title. It's related to sample movie data set. Yeah. And I have listed out every single task that you'll need to do. And we'll convene at 5:30. I was about to say 17:30. And just to give you all a hint, right, we're now going to have in place equals to true. It will edit your data frame forever. So when you're going to do your next few tasks, you might struggle a little if you forget to rerun the normal data frame again. So remember to go back to your initial data frame, run it, and then make the necessary changes when it comes to certain tasks that require the initial data frame. You all have 8 minutes left. At this point, I would appreciate it if you all could fill in the section on, not section on, the poll on which section you're on. Okay, guys, it's 5:30 and we are gonna go back to this. Let's go. Oh, yes. I'm hoping everyone is back. And okay, we had given 6 tasks for you all to do. Firstly, load the data into Pandas data frame. So this is the data that we've given you. And if we want to, I'm just going to run it so I can save again. And then we're supposed to load it into a data frame, right? So use pd.dataframe data, which is the first thing that we taught you all. Remember? So yeah, this is what is given to us. We have converted this dictionary into a data frame format. And the second task we gave you all is data cleaning. So use drop NA to find and remove rows. Oh God. Drop NA and etc. to remove rows with missing data and use .fill NA to fill missing data in certain columns. So for task 2, let's fill in the, okay, firstly, we are just gonna find where the missing data is. Firstly, there's one in rating, one in budget, one for box office. This is not necessary, but I'm just showing you where the errors are. And then we're going to create a data frame with a clean copy by dropping the rows that have errors. So you can see that 1 has error because it has an NAN. 2 also has an error, NAN. 3, 4 also has errors, NAN. So 1, 2, 3 has been removed. 5, 6, 7, 8, 9, 10, 11, 12. Everything else is fine. So that's the clean copy we have. Now we're going to run this one to fill in the data with the mean values which are present. Okay. The thing is, yeah, we want to fill it in with the average values, mean values from the previous place. Every single column that already had values, you just find the mean and then you're going to put it in. And this alters the data. So if you're going to work with this data elsewhere, then you would have to run the data again, just the pure data. So moving on to task 3. Why does this keep included? The task 3 should be selecting all movies from 2020 onwards and selecting first 3 rows and first 2 columns. So for selecting the movies after 2020, right, we make use of df.log and we specify that the year should be more than or equals to 2020. So in doing so, we can just run this one and you'll get every movie title which has the year after 2020, including 2020. And you can also and the second part of this was to select 3 columns and 2 rows, I think. Hold on. Yep, first 3 rows and first 2 columns. And so we're going to make use of a bit of slicing and learn to print that particular section. Now moving on to the 4th section, which allows you to convert the rating, budget, and box office columns to NumPy arrays and perform simple operations, which is like find the average rating, etc. So we're going to first create an array for all these rating, budget, box office kind of things. So it's not going to output it to you unless you print the array, which I don't want to. And we're going to find the average rating, which is np.mean of the rating array. So that's going to be the average rating. And then we're going to find the total box office, which is the sum of the entire box office. Then that. Wait, what else did I ask? And then the requirements were, your laptop keeps going. The next requirement was calculate the total box office, right? So we have given you the total box office, which is, I can't read numbers sometimes when they're too close. Around 22 million, 22,553,571. Okay, and then we're going to find out what is the movie profit. So when you're going to find out what's the movie profit, we find out that most of the box office has a higher revenue than the budget that they spent. So that's great. So we get the entire list. And so we want to find out what's the profit. So that will be the box office minus the budget. And you will print out a data frame of that. So we get a profit It is in this particular format, but we can do some formatting to change it and remove this. Yeah, but it is the right number for the formats. And then the next thing that we wanted to do is create a new column profit, which we have already done, and then sort the data by rating or profit using .sort values. Okay, so we're gonna say ascending is false because remember Shungsin made use of ascending is equals to true. So when ascending is equals to true, it just increases, right? So ascending goes to false means descending. So we're gonna run this and we're gonna sort the values, and we're gonna have this, which is how the ratings, the highest rating to the lowest rating. And then we also group by genre and calculate the average rating or average profit for each genre. So action has this average rating, profit has this profit is this range. So how it works is you just group by their genre, right? And then you get their mean. And that's basically it. If you have any questions, please put it into the Discord and we can try to help you. Okay, Ken. If you're, we are gonna give access to the code later. It will be, it'll be sent to you. Is there any messages on Discord? We'll give you all about another 5 to 10 minutes if you all need to clarify any questions in the Discord before we close this meeting. And congrats to everyone who has already completed all the sections. We are very proud of you. Here add a chat function. We just add chat. So now we're just gonna turn on the chat for a very short time. Within the next 10 minutes, you all can add your questions into this chat, into the Google Meet chat. We will only allow productive questions. Actually, if you all want to learn more, right, we have Shamsin doing linear algebra now.
We'll create a poll, and if you
all
want to
want
do it,
Yeah.
because I originally think we could fit it in.
Yeah, so you all can ask questions here. The chat is open now, guys. Please send your questions. The chat is now open to everyone. Whee! Hi guys, please put in the questions into the chat or like Discord. We'll try to reply because now we all have audio listening to us. The polynomial questions in them. Oh, okay. Oh, do we have any questions?
Not yet.
Is everyone actually that clear? Are you actually that very clear about the content? I think we are such amazing teachers, Shamsin.
Oh.
Okay, meanwhile, I need you all to fill in the feedback form. The feedback form is absolutely important because if you don't do it, we are not giving you a certificate. Yes. Here is your feedback form. Please scan it and do it while we try to figure out, trying to give you new lessons. Yes.
If you're done with the feedback form and you do want to like stay back for the extra part on NumPys, start around 45. Yeah.
So, were you able to y'all can't see the chat, is it? Y'all can't send it to the chat. Okay. I mean, y'all can just PM us or put it into the group chat. We have already given you our Discord IDs. Y'all can just PM us. We'll say it out loud so that you can get it clarified immediately instead of trying to like try to understand our text. Trust me, I can't get anything through message. I am more of a person who speaks. Okay, please do remember to do the feedback form. I have the QR code. And if you're done with the feedback form and don't want another lesson on linear algebra, which is like, it's going to be probably another 15 minutes max, right?
Yeah, like max.
Maximum 15 minutes. So at 5:45, we'll be starting that linear algebra lesson. Please complete your form, or I'll come in your dreams and I'll haunt you. And I'll ask you to vote for the pandas. And I'll become the president of Singapore. I sound stupid. Guys, only 38 of you all have filled in the feedback form. The rest of the 20, okay, oh, 40 people. Okay, cool. The remaining 20, all are not getting certificates, okay? You all better finish the feedback form. We need to improve as speakers, so I hope you understand that. It was fast. I appreciate.
Okay, thank you to all those people who have filled in the form and are still here. Give me 1 minute to pull out the slides. Okay, Ken. So this is quite similar to something you do in like A math at around Sec 3 to Sec 4. And the sort of syntax that you can use to solve polynomial equations with a degree up to 2 would be np.lin.elk.solve. So let's say we have these two simultaneous equations. We can first regroup them such that the constant terms are on one side, which should be all like the unknown ones, for example, y and x. We'll put them on the left, and our constant will be on the right. And we also have to make sure that the y, x, and constant are in the same format. So you can like, you can do like, for example, y minus 93x equals to 8917, and then this one is like negative 8x plus 9y, as it won't work. So how we can solve these simultaneous equation in NumPy would be, firstly, we initialize the coefficients, which would be the 4 from 4y and negative 93. We put them in like a square bracket for the first equation. And the second equation, we create another square bracket and we add it using a comma. Then we create a NumPy array, 2D array with that. Then for the constants, we also create another array for it. Oh, just give me one. Yeah, the constants will be these two, and I've created another array for it. And for the results, all we have to do is use np.lin.elk.solve. The coefficients, we add the y and x to the array here, and we add the constants, which are from the second line here. And we'll be able to get the results, which is 25.525 and negative 94.784. This would be, you can actually double check this on your calculator. And this would be just a way to automate the process if you do math. But please do not use this when you're doing your math homework because you need to show you're working. And if we do have equations with more than two variables, for example, y, x, and now we have z, we can still do the same method. We add like another comma here and add like the coefficient of z, and we add like another constant behind it. And this is a graphical representation of how it will look like. Because we have three variables, it will give us sort of a 3D array. Well, we have three equations and it gives us a 3D array. And it will look something like this. Yeah. And that's actually just a really short section. And if you do want, I will add on the questions, the optional questions for this section on the Google Colab by tonight, and I'll send a notification after I've added it in. And if you do have some time or just want to try out with np.lin.elk.solve, you can feel free to do so. And if you do have any questions after doing the practices, not just for this section, but for like any part, whether in NumPy or Pandas, please feel free to like send us a message on Discord, either through the chat or like personal message, and we will be very glad to answer them. Yes, please give us work to do. Yes.
100%.
That we have officially come to an end of the NumPy and Pandas workshop, and we are very sorry that we have to cram two I'll say quite large libraries into just 3 hours. But we hope that you have learned quite a lot from this workshop. And right now, if you do want us to re-explain or like go back to any slides, please feel free to like send us a message and we'll And we can go through the slides once again and explain it if you need. Yeah. Else, if you haven't filled in the feedback form, please do so before leaving. And if you have filled in, have a nice Monday, and thank you for coming to the first day of BBCS workshops.
And I hope you have a great March holidays.
Yes.
Enjoy yourselves.